Hi everyone, welcome back to another very exciting day of graphing trig functions. So today we're going to venture away from sine and cosine and kind of look at some of our other trig functions. All right, so this first one, y equals 2 tangent of x minus 5. All right, so the first thing we're going to do is graph our parent function here. I'm going to put a really big y-axis here, only because I see that I have an a value of 2 and a value of 5 there, so that's going to involve a lot of different things. All right, so pi over 2, pi, 3 pi over 2, 2 pi. Probably didn't need such a long x-axis, but that's all right. All right, so then you have to remember what tangent looks like. And so you can go to the front of the page here if that helps you. But basically you have to remember there is a vertical asymptote at pi over 2 for tangent and 3 pi over 2 for tangent, which means the other values are at zeros. Right? And then I realize I got to label my y-axis, which I didn't do yet. 1, 2, 3, -1, -2, -3. And I'm going to keep going here because I know I'm going to end up down here. All right. So back to where I was. 0, 0. All right. And then I'm going to go up here. I'll have a 0 at pi. And a 0 at 2 pi. And there's what I need to have a good looking graph here for tangent, for the original tangent. All right. Now I can see that there is an a value of 2. But here's the thing with the a value of 2. All right, it wouldn't necessarily affect any of the zeros or any of the asymptotes. What it would technically affect is if I got real nitpicky, technically there is a point here at pi over 4, comma 1. Technically that stretches to 2, but the zeros are going to stay the same. And so what you didn't realize is I'm technically put points here. You just didn't realize it. All the over 4s, halfway between all the over 2s, technically are 1s and -1s. So technically, those double there, and that's where that stretch comes from. All right, if you don't graph those, I'm not going to be super picky about it. If you ask Mrs. Hoffman, she might be a little bit more picky. All right, that's kind of a personal thing. But there's my a value of 2. All right, and then I need that is a d value here. There's a d value of -5. So what happens here is the vertical asymptotes don't move anyway. So what I do need you to do is retrace them in whatever color you're going to say is your final, because for this one, you don't have a shift, right, of these vertical asymptotes, because up and down won't change it. So re-highlight those in whatever color you're using. All right, but then all my zeros are going to move down by 5, so that point's going to move all the way down here. If you choose to include those extra pi over 4 values, those would move down here. Right, and so that would move all the way down to here, and here, and here, and since I'm including them everywhere else, right, I'm going to show them, but again, if you don't use them, not the end of the world. And then you'll see up, and tangent here, and it only has that half. If you keep drawing this tangent, which is what I typically do, all right, that's fine. If you don't need it because it's only 0 to 2 pi. All right, then I venture over here and I start to do domain and range and amplitude and period. And I'm going to do these out of order just because it's easier this way. All right, there is no amplitude because this is not sine or cosine. All right, it's not a wave. All right, so as soon as I see that, that does not apply to any of our other trig functions beyond sine and cosine. All right, so range is probably the easiest. Range ends up being all real numbers. All right, any one of those red pieces, if you extended it the full way, that middle piece especially shows you all real numbers. All right, if you think back to domain, all right, this is all real numbers except for where the asymptotes are. And you have to think back to what we talked about with asymptotes from the other chapter. All right, the first asymptote is at pi over 2. And then it happens every pi units. So that's plus pi n. All right, so it's all real numbers except for pi over 2. And then every pi units after that, there must be an asymptote. All right, The period, and tangent is special, tangent and cotangent are the only ones where the period is pi, not 2 pi, because again, only one of those pieces of the graph is needed to get a full picture of what you're doing. All right, so there's your tangent graph. All right. The second one of the day is going to be a cosecant graph. So for cosecant, it says cosecant of 8 times x plus pi over 5. That's a b and a c value. As soon as I see b and c values, I know that's going to get me to do that inequality. And so that's the first thing I'm going to do here. Before I draw the graph, before I do anything else, all right, I'm going to do the inequality. So 0 to 2 pi, put that b and c combination there in the middle, and we're going to solve. So the first thing I'm going to do is divide everything by 8. So that will get rid of the 8 in the middle. 2 pi divided by 8 is going to get me pi over 4. Right, pi over 4. And then the step of math I need here is to subtract pi over 5, which isn't going to be hard from the left-hand side. But on the right-hand side, I'm going to make you do some fractions. All right, so if I subtract here, that'll get me negative pi over 5 is less than or equal to x is less than or equal to. Now, I have to think about this for a second, and so I'm going to kind of go off to the side here to do this. I'm going to try to zoom in. 5 and 4, if you think about what a common denominator would be, the answer is 20. That's the least common multiple. So pi over 4, well, that becomes 5 pi over 20. And that pi over 5 that I'm subtracting, that's 4 pi over 20. So this math right here gets me just good old 1 pi over 20. All right, so that ends up being the other side of my inequality is pi over 20. All right, this one is going to be trickier because we're going to have a lot of fun with fractions. And so even before, again, I go over to the left-hand side here and I start even trying to figure out what my graph looks like, it's probably a good idea for me to figure out what my 5x labels are. And so I'm going to do that first this time. So we're going to look at pi over 5, and then some value, some value, some value, and pi over 20. All right, so to try to figure out, well, where the heck do we go in the middle here, all right, I'm going to convert the pi over 5 here into negative. This is 4 pi over 20. And this is positive 1 pi over 20. So that's a total of 5 pi over 20 difference if I subtract those to find the range. All right. So to find the middle of 5 twentieths would be 2.5 twentieths. All right. So in either direction here, you need 2.5 over 20. Because again, from here to here is 5 pi over 20. Okay, well, that would make this 1.5, negative 1.5 out of 20. Well, that doesn't make any sense to have a decimal in there. So if I double the top and the bottom, this becomes negative 3 pi over 40. So again, I figured out the total difference between the left and right values is 5 pi over 20. Halfway in the middle would be half of that distance, so 2.5 in either direction. So if you take pi over 20 on the right and subtract 2.5 pi over 20, you'd get negative 1.5. Or on the left-hand side, negative 4 pi over 20, and add 2.5 pi over 20, you get that negative 1.5. And again, I'm turning that into negative 3 pi over 40. That's my middle number. All right, so I'm going to switch colors here to try to help you some more. All right, so now I got to find in between a 40th, and I'm just going to get rid of all my domain and range here. That's going to move. We'll worry about that in a minute. All right, so now I got to go between a 5th and a 40th. So for that, I'm going to get creative, and I'm going to change my values here. All right, and so I'm going to make this go away. You can go back if you need to for that. All right, so now the common denominator between negative pi over 5 and negative 3 pi over 40, all right, would be over 40. So this is negative 8 pi over 40 and negative 3 pi over 40 here. And this would become 2 pi over 40. All right, so from here to here, this distance is 5 pi over 40. So again, half of that means to go in either direction would be 2.5 pi over 40, because we want the halfway mark. All right, so negative 3 pi over 40 in the middle. If I subtract 2.5 pi, this is negative 5.5 pi over 40 would be the midpoint, the middle between those two things. Math will be the same over here. This is going to be negative 0.5 pi over 40 because, again, 2.5 in either direction. Now, again, we don't leave the decimals with a fraction, so I'm going to double the top and the bottom here. This becomes negative 11 pi over 80 and negative pi, 1 pi, over 80. The fractions are probably the hardest thing about this problem, is trying to understand where those 5x values are that I'm going to need to label in my equation or in my graph. All right, so again, it's all about finding the midpoint, so finding exactly halfway in either direction. All right, and then once I have that middle value, that negative 3 pi over 40, same thing. Figure out how to get halfway in between either one. So you look at the total distance, cut it in half, and then that's what you add or subtract to get to the middle numbers. All right, so these 5 numbers, notice 4 of them are negative, 1 of them is positive. So when I go over here to go draw my graph, my x-axis is kind of going to be towards the right-hand side. All right, so what I'll do is here, since normally I count every other block, pi over 20 is going to be 1 block over this way. All right, every 2 blocks means that's the next one. So this is negative pi over 80. 2 blocks over will be negative 3 pi over 40. 2 blocks over is negative 11 pi over 80. And then negative pi over 5. That's going to be how I label, all right, my x-axis. All right, don't forget to label the y's. I always forget to label the y's. So I'm telling you right now to be better. There we go. But the nice part is, after that exhausting process of doing the B and C values, there's no A value, there's no D value. So right here, right now I can just copy kind of the general idea of what we usually see for cosecant. And usually for cosecant, we start with an asymptote. So I'm going to draw an asymptote here. And at the 3rd spot, and at the 5th spot. And then I usually have a point at positive 1. So my graph will look like this. And the other one will be at negative 1. Unfortunately, that's right in my label. Sorry, negative pi over 80. And then it'll look like that. So again, the B and C inequality makes that really, really tricky. But once we figure that out, all right, this one's not that bad. All right, so I'm not going to forget about my domain and range and period here, so I'm going to drag that over here so I got a little bit more space. All right, my domain is a little tricky here. All right, it's going to be a little tricky. Just like with tangent, it's going to be all real numbers minus. And then for this one, the first asymptote that I see, all right, and you can look at either the positive or negative, but I'm going to look at the first one that I see on the negative side. That is negative pi over 5 is the first one where I drew it. And then you got to figure out, okay, well, what's between, like, what is the distance between negative pi over 5 and negative 3 pi over 40? So if you think back, this is negative 8 pi over 40. So that distance between that value and the next asymptote is 5 pi over 40. Right? Again, if I just subtract those values, the difference is 5 pi over 40. That is pi over 8 in length. Again, asymptotes and these x values are going to be tricky, but you work through that. All right, my range of this one is the range that I would normally have. So negative infinity to negative 1 and 1 to infinity. My period is not 2 pi anymore. So if I figure this out, the distance between negative pi over 5 and pi over 20, that is pi over 4 in length. And you can do that a couple of different ways. You can use the formula, which is old period divided by v value, which would be 8. Hey, that's one way to get pi over 4. All right, you could also figure out, okay, negative pi over 5 to pi over 20. Well, that was negative 8/40 to 2/40. All right, that's a difference of 10/40, 1/4. All right, again, those are going to be one of those where you're just going to have to try it a couple of times, and then if it doesn't make sense, we'll figure it out together. All right, the third graph, all right, third and final one of the day, is y equals negative secant 2/3 x minus pi over 2, close the bracket in the parentheses, all of it plus 4. So, hey, now we're going to see one where it's one of those strange, not sine or cosine graphs again, one of the other trig functions. And we're going to see an a, a b, a c, and a d value, all of it in action at once. And so, like the others, I'm going to go take that b and c combination and do that inequality first. So 2/3 x minus pi over 2. Set it between 0 and 2 pi. So what we're going to do here is multiply by the reciprocal is going to be the ideal thing. So multiply by 3/2 everywhere. All right. 3/2 times 0 is still 0. The 3/2 and the 2/3 will cancel, so this is just x minus pi over 2. And 3/2 of 2 pi is 3 pi. Add a pi over 2 everywhere. This becomes pi over 2. 3 pi is equivalent to 6 pi over 2. Add another pi over 2. You are at 7 pi over 2. All right. And what I'll do is, just like last time, I'm going to move the domain and range probably to somewhere down here, and I'll worry about it in a minute. So I know this is pi over 2. I know this is 7 pi over 2. So I know that distance, first of all, is 6 pi over 2. That's a distance of 3 pi. Hey, I'm going to go cheat and fill in the fact that that's 3 pi now. All right, because I know that distance is 3 total pi. All right, so what's in the middle of 1 pi over 2 and 7 pi over 2? Well, that would be 4 pi over 2. Hey, that's just 2 pi. Now, all right, I'm going to put 2 pi up here and circle it because I'm going to get it out of the way for my next part. Now, to figure out what's between 1 pi over 2 and 4 pi over 2, well, that's a distance of 3 pi over 2. So I would need something that goes 1.5 pi over 2 in either direction. All right, so if I take 4 pi over 2 and subtract 1.5, that would be 2.5 pi over 2. I don't like the fraction and the decimal, so I'm going to double the top and bottom here. This becomes 5 pi over 4. Likewise, this is going to have to be 3 pi over 2 total to go from here to here. So half of that is 1.5 pi over 2 in either direction. So 4 pi over 2 plus 1.5, this would be 5.5 pi over 2. Again, double the top and bottom to get rid of the decimal. This would be 11 pi over 4. All right, now I have my 5x values. All right, that's going to be really helpful here because draw my x-axis. All right, and I'm going to need an x-axis that has a decent length to it here. So I'm not going to start right by the origin because it starts at pi over 2. So you can do this. I'm just going to go one value over because here would be pi over 2. And then this is 5 pi over 4. 2 pi, because that's simplified all the way to 2 pi. 11 pi over 4. And 7 pi over 2. All right, those are my 5 x values. And then if I draw the parent graph in here, all right, for secant, all right, I know that I'm going to start, I'm going to go back and label here. I always forget this. -2, -3. All right, my parent graph here. All right, cosine starts at 0, 1. So this one has a starting value here at 1. And then every other one is an asymptote and a -1 and an asymptote and a +1. And much like cosecant, all right, and it's up to you. You can technically extend this if you want and get 3 full curves there if you want. All right, or 3 full pieces, not 3 full curves. All right, it's up to you. If not, that's considered the 1 period option. All right, so that took care of the B and the C values. All right, I still got an A value out here of -1. All that's going to do is reverse, all right, my Y values. So these 2 points up here at something comma 1 will go down to -1. The one that is down at -1 will jump to +1. It'll flip the graph upside down. It will not affect the vertical asymptotes. All right, it won't affect the vertical asymptotes. I'll trace over it just to make sure. All right, nothing changes there. All right, and then the last value on the graph, all right, well, that is a D value of 4. Everything's going to move up 4 values. So looking at my points that are in green, 1, 2, 3, 4, that value moves up here. 1, 2, 3, 4, that value moves up here. 1, 2, 3, 4 here. And again, shifting up and down does not move my asymptote, so I'm going to trace over it in one more color here in purple. All right, that'll get me my asymptotes for the final. And then, all right, now the tricky part is this first point you're going to want to go up, but remember it flipped upside down. This goes down, the middle piece goes up, and this goes down. And again, if you want to extend and extend, that's okay. And if you don't, that's okay too. All right, so move my domain and range a little bit here to try to get this. Oop, it didn't take the pi with it. All right, there we go. The domain and range, all right, the range, if you look at it carefully, the bottom pieces are from -infinity till 3 is where the 2 other pieces stop at. And then the other piece goes up at 5 and goes up to infinity. All right, so there's the range. The domain, if we look at the domain, all real numbers except, and then you tell me where the asymptotes are. The first asymptote is at 5 pi over 4. All right, the first one is at 5 pi over 4. Figure out the distance between 5 pi over 4 to 11 pi over 4, where the next asymptote is. That is a difference of 6 pi over 4, which is 3 pi over 2. So this is plus 3 pi over 2n. All right. So there we go. All right. Hopefully this makes enough sense. Thanks for watching. We'll figure some stuff out, ask each other questions. All right. And we'll do this again tomorrow.